Hello everyone, welcome back again to the channel if you're not new here, and if you're just joining on this session, please feel free. We've been working on a series, 4 series actually, so this is the 5th video on that series, and from whatever we had built before, this is what we have as the UI for what we've been working on. So we've been working on the backend and the front end just to get it to work in the server, but we haven't really talked about the database and how do we set up database so that our backend can be able to access that database. For those who have worked with the cPanel, I don't know whether it's possible, but it's usually hard. I haven't really succeeded in being able to expose a database service to external services so that you can reuse it in other applications in different location other than the point where you bought your domain or your VPS is hosted. So if you have a bare metal server, that means you can be able to leverage the power and capabilities of the server to host your database services, the backend and the front end. So what we're going to be doing is we already have a repository set up here for SaaS database services. That is, we'll be building it ground up to make sure that we have everything hosted. So what we'll try to put in place, we'll host MongoDB. That is number one. We also have PostgreSQL, and if you so wish, you can go ahead to host MySQL, but I will put Redis, MongoDB, and PostgreSQL. I think those, if those are gotten right, then the rest should not be an issue. So also to add on the same, we'll need a way to probably look at the logs of our containers, how they are running. We'll install a tool known as Portainer for managing the containers and checking their health status and the resources they're utilizing. So if I get back to VS Code, you'll see that I already have downloaded the repository. I have cloned it locally and there's nothing here. So we'll start building. The first thing is we'll create a folder known as let's start off by having some environment variables. We'll start off by ignore.git ignore. So in here we'll just have .env. Then we'll add a .env. After the .env, we'll have a .env.example. After having this, then here we'll have db user, which will be a string, db password, which will also be a string, db name, which will be just a string. Then I'll explain this later. Venture db. So let me just copy this and put it in the .env here. In the .example, we don't need that. So the .env will have the data there pointing to 2 steps backward in the folder where we are. that is the database services. So we move to one step backward, then we go to the venture DB. User will just be Orinda, then password will be pass, then DB name will be Orinda. Let's have it as password 1234. Password at 1234. So once you have this set up, your password at 1234, DB user is Orinda, and we have the DB name is also Orinda. So let's set up, let's just commit this. So commit sync. What we will need now is we'll craft, I'll explain how we are going to write this. So we'll craft a YAML file, a Docker compose file for carrying all this. You can easily set up these things without necessarily using a Docker file, but just using the compose file. So we'll use the compose file for building this, but if you feel you need extra hand or extra configuration, you can create a folder, then add a Docker file, then set up the way you wish to put it up. So we'll create a file known as docker compose .yml. So let me just remove that. Version. So version will go with 3.8, but we also have 3.9. Then key thing when you're writing your compose file, you need a services section. So this is where now you document your application. So we'll have Postgres. In here, we'll have restart as always. This means that whenever we boot up our machine, it should be able to start automatically without being restarted. Then container name, we just call it Postgres. Image, this will be Postgres. Let's have 16. So image now will point to, if we remember, we had this backend which had a Docker file. So the image will point to this from where it's supposed to be pulling. If we were not to specify that, then we could just specify the location where the Docker file is located. Then we just point build to that location. But we don't need that for now. We'll just specify the image and it should be able to pull from there. Port, we'll have 5432, then 5432. This is the host, this is the container. env, you can specify the env file. With me, I'll just specify the environment, then we'll add Postgres. If we check on the Postgres official image, the way they start it off, you'll see there's Postgres DB, Postgres user, we'll have the Postgres user, Postgres user. Then this one will point it to so this will be db user, and another aspect you can use this approach. Then Postgres DB. Then we have DB name. Then we have Postgres password. We have Postgres password, then DB password. So this should be able to point to the env variables that you're having. We won't specify the environment variable file because it's in the same location with the docker compose.yaml. From there, we can run docker. We need to set up volumes for this. So docker volumes. One of setting volumes, we can specify pg data. Then we point it to varlib PostgreSQL. Then we'll have our data. If we put it this way, this one will be automatically handled by Docker. So you need to specify here volumes, then put it like this. But because we won't be taking that approach, I'll just use the data dir that we had specified. So accessing the environment variable which have been specified in the .env, we'll use the $, then the quotation, the curly braces, and the variable itself. So I'll have it as data dir, the data folder that I've specified, then we have the pg data inside it. So that will be pointing to where our Postgres will be. So I can just run docker compose app, then build. Should be able to pull Postgres. Then it should be started. So if, just to confirm if whatever we have is working, you can see connection not established. Test this. You'll see client password must be a string. So we have a render password 1, 2, 3, 4 test. We had Orinda test. Then you can see we're able to connect with whatever we had specified here, where the user's Orinda, DB name as Orinda, and DB password as Orinda, and we're able to connect. So this means even if let's just test this. It's persisted, and just to confirm whether it's there, if we go back, then we list the folder which is in the env is venturedb. So you can see we have this folder venturedb created. So if you go to that folder, you can see it's locked. That means it's read-only. Okay, if we list, we can see we have pg data. So if I go to pg data, I'm not allowed to go into that folder, but we can run sudo ls pg data. We should be able to see some files based on Postgres, and we don't need to worry about this because Postgres will handle this for you. So that is it for PostgreSQL. That's how simple it is to set up a persisted database with the Postgres. But if you need more complicated setup, you can add a Docker file in a given folder, then specify the build steps in here. So we can commit that as add Postgres, add PostgreSQL. Then we can sync that up. Next up, we need a way to visualize our containers. Okay, currently we have no way. We just need to run docker ps to check for running services, of which you'll see we have only this Postgres 16, which is running because we've just built it now. And docker ls, if we check the images, this will give us a list of all the images that have been built locally and the ones which have been downloaded, and you can see so many are here and some are not in use even. But if now we'll be having that visual approach of seeing this, it would be very easy for us to manage them. So we've finished up with the Postgres service. So I'll add a Potena service. It will require me to add an image. This image will point to Potena, then Potena CE. So Potena CE, I just have it like that. CE. Then after I have it, then container name will just be Potena. Then we can have a command. Let's just have port. We'll allow it to run on port 9000. The first 9000 is for the host machine, and the second 9000 part is for the container itself. So okay, so from there we'll need a volume. So its volume will be pointing to var Okay, var run docker dot sok, then we copy that and paste it here. Then we can have Potina data, which will be data. Then that should just do it. We need to create a volume section and pass this Potina data there. So also we need to make it restart always, so that whenever we launch up we start these services, it always starts. So we can try and run this docker docker compose app-build-t. Then you can see container, the Potina is there, and the container is running. So if I need to, for us to confirm if Potina is working, we can head over to localhost 9000. So if we go to port 9000, we will be greeted with this. You'll see potina.io, which means this is service which you can self-host. So I'll just create a new user with the passwords available, then click on get started. After getting started, you'll be able to see we have 1 stack, 2 containers, and 7 volumes, and 22 images. So 22 images, those are a list of images which have been built locally and those which have been pulled from Docker registry. So if we come to images, you'll be able to find we have some images which are being used and some which are unused. So I can add this to reach 100. Then click on this, select all, then remove. So the ones which will go with the green, that means those are images which are in use, but the ones which come out as green, that means they have been removed successfully. But those which shows you red border, that means they are in use and they cannot be removed. So the nice thing about persisted volumes is that if I remove a container, it doesn't really alter a lot. I can just re-download another container, then mount the volume, and it should be able to pick from that volume and restore the data as was before. So that makes it really convenient if in case you're handling user data that may require you to store it somewhere for later reference. So you can check on the containers here, then you can see we have Potina running and Postgres running. So if we check on the Postgres, on here we can check the logs. It will show you the logs for Postgres. If I go back, then look at this, the stats, which will show you how it's performing based on memory, CPU usage, and IO, and also the network usage. So those are some of the things you can explore from this dashboard. It doesn't do everything, but better part of things you'd wish to manage your services in the server are just here. So once you have this in place, what we've added is add Potina, for monitoring DB services commit so next is we need to deploy this, but before we deploy we can add Redis. Redis will also take the same approach. So for Redis, what we'll have is just image, which will be Redis 6, was it 6.2? Then container name, which will be Redis, then restart always. Then we can have the ports, which is 6370, and 6370. After ports, then it should just be that. You can have environment. The environment, what we can have is just Redis password. Which should point to DB password. That should be able to pull for us Redis. If I run docker compose, build, should be able to see it's pulling Redis. Then once Redis is pulled, we should be able to see Redis started. We come to the containers, you'll see Redis is running and you can see the logs. Yeah. Next up is let's commit this, add Redis, sync. So I'd said we'll use MongoDB. So for the MongoDB, it will also take just a similar approach that we've used for setting up Postgres and these other services. So what we'll need to write is add a service name, Mongo. So for the Mongo part, we'll go for MongoDB. Image name, Mongo. So if we check in the Docker registry, official images, we have Nginx, Mongo. Where's Mongo? we have Mongo. So we have Mongo there. What versions do we have for it? So if we check, so you can see these are some of the setup based on the documentation we are having. So you'll need in the environment, you'll need init the root DB username and the password. So we'll just copy this to the environment. So this one will copy, paste, DB user. We'll add the container name, Mongo, then restart always. Then you can have a volume section, which should point to data dir Mongo, then should be pointing to data DB. That should be it for Mongo. If I rerun this to build, should be able to pull Mongo. I'll kind of wait for it to finish pulling the image, and you can see Mongo is already started. You can confirm by going to our container, checking for the containers, and you can see we have MongoDB running here. So everything looks to be working as expected. So up to there, I think it's okay to say that this is just enough to make sure that you have a persisted volume, that if you mess up things, you can always get back to this and restore your data. So the main difference is for this container data, you can see this container. This maps to this side, and for this named one, this is automatically managed by Docker, and if you specify a path, then it will handle that automatically for you, and you'll be able to see the folders by yourself. So that wraps it up. I think I'll commit this so that the next one, let me just have a deployment script so that add MongoDB sync, then go to deployments, after that, then I can take whatever we had in the backend, copy it because it's something which is reusable. Go to GitHub, deploy. There's few things we need to change here and there. That includes removing. We don't need node version. We don't need all this. So if we come to deploy, let me just copy this, all of this. So what we'll take out are these parts because we're building nothing. So from SaaS backend to SaaS DB services, DB services. So this will make sure that when we push anything here, we'll also get notified. So let's copy, update Docker file. Commit. Sync. So these ones I think we had already done, and later on I'll move through them, but for now we can stop at that. Then the next will be deploying this to the server. So I think with that we can call this off, so that the next one I will deploy it in the server. After deployment, then now we can connect it to the backend and see how it works. Let's meet in the next 6th series.